So the reason for using determinants of matrices is to solve linear equations. We've already determined how to solve linear equations by substitution and addition, but now let's look at how to do it with determinants. This is called Cramer's rule. So we're given this set of linear equations, and what we do is we find three different determinants for two variables, okay? We have to find D, which is your x and y of both equations, the coefficients of those. Then what we're going to do is we're going to find D sub x, which is the determinant. We're replacing the x coefficients with the results, E and F over here. Notice my y coefficients stay. This is for D sub x. D sub y, my x coefficients stay, and I replace the coefficients of y with my results. When we do this, what happens is that x is equal to D sub x divided by D, and y is equal to D sub y divided by D. We do have to pay attention, D cannot be 0. If D is 0, we cannot use this. Now on the first example that we're going to do this for, we could use elimination or substitution, either one, but I'm going to show you why we would want to use Cramer's rule, and a lot of it is because we end up with those nasty looking fractions that no one really likes. So let's start with finding our D. Our D, remember, is just the 4 and the 3, understood 1, and a negative 2. So whenever I find the determinant of D, that's going to be 4 times negative 2 minus a 1 times 3. So D is equal to a negative 8 minus 3. So D is equal to a negative 11. So now let's go to D sub x. And I'm actually going to leave the y's the exact same, 3 and negative 2, but I'm going to change the x column to these results, 2 and 5. So you'll notice that the 3 and the negative 2 stayed. I changed the x column, which we're finding D sub x. So now D sub x is 2 times a negative 2 minus the 5 times the 3. So D sub x is equal to a negative 4 minus 15. So D sub x is a negative 19. Now I'm going to find D sub y. My x values in this case are going to stay the same as my original matrix. My y values are what are going to be replaced by these results, the 2 and the 5. So notice the 2 and the 5 are going to go in the first column for D sub x and in the second column for D sub y. So now I have 4 times 5 minus a 1 times a 2. D sub y is equal to 20 minus 2, so D sub y is equal to 18. To find my actual x value, I'm going to take D sub x and divide it by D sub y. I'm sorry, by D. So my x value is going to equal a negative 19 over a negative 11. Not much I can do with that because I do want to leave them as fractions because otherwise I get these atrocious looking decimals. So x is equal to 19/11. Now I'm going to do y. So y is going to be d sub y over my d. So y is going to equal a positive 18 divided by a negative 11. So y is equal to a negative 18/11. So my solution for this set is going to be 19/11, comma, negative 18/11. This is my solution for this. Now I could have solved this one for x and substituted, but notice these nasty looking fractions. I don't want to do that with the fractions because I'm going to end up with some pretty bad numbers, okay? And I know how we all love fractions so much. So Cramer's rule actually helps us stay away from the fractions until the very end. That is one advantage of it. So try using Cramer's rule with just systems of equations with x's and y's, and then we will look at them, okay?